Hello friends, today our topic is the square matrix. In the previous video lecture already we have discussed on the different types of matrices, and there already we have discussed about the square matrix. Now today we are defining the square matrix elaborately. If square matrices have n rows or columns, then the matrix is called the square matrix of order n or an n square matrix. Once again, n square matrix. What is the definition of a square matrix? Now, an n cross n matrix is said to be a square matrix of order n. In other words, when the number of rows and the number of columns in the matrix are equal, then the matrix is called a square matrix. Just like for the example, suppose A is the name of the matrix. Now here we can check the number of rows are 3. The number of rows are 3 and the number of columns are here, that is 3 also. So that is the matrix of order 3 cross 3. So when the number of rows and number of columns are equal, that is called as a square matrix. So that is the example of a square matrix. As usual, the number of rows of the above matrix is equal to 3 and the number of columns of the above matrix is equal to 3. Since the number of rows and the number of columns are equal, the above matrix A is a square matrix. Let's check another example of another matrix. Here that is the name of the matrix is Z. Now look at the matrix number of rows. Here row 1, row 2. So number of rows here 2. But check at the number of columns. Here the number of column is equal to 3. 1, 2, 3. So the order of the matrix is 2 cross 3, where the number of row and number of column are different. So that is particularly not a square matrix, that can be treated as a rectangular matrix. Already we have said in the previous video. So the number of rows of the above matrix is equal to 2 and the number of columns of the above matrix is equal to 3. Since the number of rows and the number of columns are not equal, the above matrix Z is not a square matrix. Now when we are talking about the square matrix, another term that is connected with the square matrix, and that is the diagonal. The diagonal through the left hand top corner, that must be R, left hand top corner element of the square matrix is said to be the principal diagonal of the square matrix. Once again, from the left hand top corner, that means from here, and that is called as a principal diagonal of the matrix, and the elements in the principal diagonal are said to be the diagonal elements of the square matrix. Let us check the example. The first one matrix name is A. Now that is the left hand corner, and those are the diagonal elements. Using the red colored numbers are particularly the diagonal elements, and that is the principal diagonal. If you can check, the number of rows is here, that is 2, and the number of column is also 2. So that is a 2 cross 2 square matrix or 2 square matrix. As already said, n square matrix, that is 2 square matrix. In the above 2 cross 2 square matrix A, the diagonal 8 and 6 is the principal diagonal, as we have crossed out it, and 8 and 6 are said to be the diagonal elements. Let's check the second example, and here that is a square matrix of 3 cross 3, because the number of rows are 3, number of columns are 3, and the red colored elements are particularly the principal or the diagonal elements 7, 2 and 6. In the above 3 cross 3 square matrix Z, The diagonal 7 to 6 is the principal diagonal, and 7 to 6 are said to be the diagonal elements. Same as for the 4 cross 4. Here check the number of rows are 4, number of columns are 4. So that red colored element 8104. In the above 4 cross 4 square matrix P, the diagonal 4104 is the principal diagonal, and 8104 are called the diagonal elements.